Hello guys, and welcome to this video tutorial of Inventor 2018. Today we will be doing a little bit of reverse engineering. So a good friend of mine, our friend Mike, has sent us a picture of this Sprocket. It is apparently not being produced anymore, and the last one, or one of the last ones, in the UK. So our job is to actually get a 3D model of it, so maybe some manufacturer can produce more of them. So I'm going to open up Autodesk Inventor. As usual, I will start 2D sketch of my XY plane. What I've done, I've taken a photo of the gear, so we have some reference geometry, since I don't have any special measuring tool or any 3D scanner, only a vernier and a camera, so we have to work with what we can get. So I've got my image here. I'll open it. So I've just clicked there on image and I will import my image now. Okay, so that's the image of my gear. The first thing I'm going to do, I'm going to draw some reference geometry. So I'm going to draw a circle here. So you can see it does not fully fit, simply because it is almost impossible to get the sprocket exactly in the center of the photo, in the center of your focus. So, however, we can fix that. So I'll add a couple of dimensions. Actually, before I do that, I will use a fixed constraint, and I will fix my midpoints. Just these two. Okay, so with those two fixed now, we can add a dimension from the midpoint to the center. Another one there. Okay, it's a bit offset, so we'll try 143. Still to offset, maybe 143.5. Maybe, as you can see, there is still a bigger gap. Maybe 143.75. That looks a little bit better. And now let's make this one 142 and see what happens. Maybe 142.25. And now let's adapt this. So you can see that's pretty close. That's probably the closest you can get to the picture. So now, after doing this, now that I've got it exactly at the center, I will get rid of this constraint, and I will get rid of this constraint as well. Oops. Not the dimension, only the constraint. Okay, and now I will use I'll dimension my circle, and now I will use a coincident constraint to place my circle right at the center. So I've now got my sprocket perfectly at the center. Now I need to orient it, because even though it is at the center, that tool is not perfectly aligned with my y-axis. So in order to align it with my y-axis, I'm going to use the rotate tool. I'm going to click on my image. I'm going to select my center point. I'm going to ignore this message and I'm going to give an angle of 0.6 per mil. That should be roughly what we need. 0.5, 0.6. So yeah, that's pretty accurate. So you can see it would be right at the center. Okay, so the next thing that we need to do, we need to scale this down. So I have measured this with a vernier, and I know that my original geometry is the diameter is 27 mil. So I will copy this this diameter, Ctrl C. So now when I go on scale and use the scale tool, I'm going to select my photo, my circle as well. My base point is going to be the center. You have to ignore the message, so it gets the constraints removed. And now here where it says scale factor, so if I want it to be 27, that would be 27 divided by the dimension that we just copied. So I'll just paste it and I'll click on apply. So as you can see now, the picture has been scaled down to 27. So now I've got a right one-to-one model. So now what we'll do, I don't need these dimensions anymore, I'll get rid of them. And I will use a fixed constraint to fix my picture so it doesn't move. And I will also fix this circle. Okay. That's good. So now that I've got my main tooth centered and that my gear is exactly centered at my origin point and also scaled to the real dimension, I can start sketching on it. So I'm going to draw a second circle at the center. From my model, I know that this one is 40 mil. So you can see it fits quite well. And now I'm going to draw the top of my tooth, which I know that it is 1 mil long. Actually, I'll draw half of it, so it will be 0.5 mil. And now I will use a vertical constraint from this endpoint to my center. That's it, that will be half of my tooth. And now I'll move it a little bit up. So right now, what we'll do, I will create a few points. So if I go on point, I'm going to place a point roughly here, another point roughly here, because I know that it's made out of 2 arcs, and then another point. Actually, before I add that last point, I will just add my angles instead. So first I'll draw a vertical line from this end line to my center. I'll right click turn into a construction line, so you can see. And now I'm going to draw another line going all the way through, maybe up to here. Another line also from here to here. I'll also turn them into construction lines. And now the next thing I will do, I'll add an angle in between them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 teeth. Okay. So this will be 360 degrees divided by 13. That will be my angle. And now my angle from the center will be the overall angle divided by 2. As you can see, that's our last point will go here. Okay, perfect. So now we can trace that. So I'm just going to create an arc that goes from here to here. So sticking out a bit because the teeth in the real model are a little bit worn, so I'm giving this bit of extra margin under the assumption that the original ones are worn and the new ones need to be. I'll move this arc a little bit more. That needs to go down to here. So I know that it has 2 different arcs. 2 different radiuses. I'll give this a dimension as well. And my last one goes from here to here. So it needs to come out a little bit. Just keep going a little bit too. Just notice that these 2 lines were moving, so I'm going to fix them first. So yeah, I thought that all these lines need is a coincident constraint. So now that they are constrained there, we can add our final arc that goes from here to here. So we've got our geometry now from these 3 points. Now what I will do, I will give them dimensions. And now we'll just draw on top of this. So I'm going to draw them up to here. So I've got all of my dimensions now. Now the next thing I will do, I will mirror this. So I will use the mirror tool. And mirror this on the other side. So this is going to be my mirror plane. And apply. And now we'll just trim this bit. This bit as well. This bit. Okay, so I've got my geometry now. I can finish my sketch. And now I can extrude these by 8.5. In this direction. Or actually, I'll do it in the opposite direction. You will see why in a minute. I'll click on OK. Okay, so that's done. Now the next thing I will do, I will use a circular pattern, and I will pattern this solid around my Z axis. And I want 13 of them. Because I calculated my angle correctly, it perfectly matches it now. So that's half of the job done. Now we need to add a couple of features. Okay, so the first one that we're going to do, let me see what side place my picture. Okay, so my image is here, so I'm going to do on the front face. I'm going to start sketch on my XY plane, sorry, my YZ plane. I'm going to use slice graphics so I can see through. I am going to project my cut edges. Perfect. And now I will draw my geometry on top. So I've got something like so that's 20. I know that the distance from here to here is 26. I know that the distance of this one is 14.5. We can make probably this one constant to this one, and now we just need to give this one another dimension, which in my case is half my diameter, so 13.5. Okay, So that's all correct. So let's finish the sketch. And I will use the cut option, full extent, and my axis will be my Z axis. Sorry, I will use join, not cut. There we go. So that's the second part of it done. Now I will also start sketch on the same plane, my YZ. I will also use F7, slice graphics, project cut edges, and I'll draw my next sketch. So this one will be something like okay. So now that I've got this, I'll give it my dimensions that I measured with my vernier. So that's 6.5. This is 19.75, and this is 25. Okay, that's good. So now I will finish my sketch. I will use revolve again. I will see if I can find my profile. There we go, found it. Select the cut option this time instead of join. Select my axis, which will be my Z axis. It will cut all the way through. So now click on OK. So that part is also done. So now we just need to do our spline that connects it to the shaft and taper our teeth. So we will start with the spline. So I'm going to right click on my image. Oh, sorry, my image is on, it's my sketch. I'm going to right click on my sketch 1, turn on my visibility so we can see. Now I will probably want to sketch on this face, for instance. And I can proceed to draw that geometry. So what I will probably do now, I will just turn my sketch 1 off, copy this image and paste it onto my new sketch. That's a lot better, a lot cleaner. So I'm going to start by drawing my vertical line. I'll first draw my circle, which is .27 mil diameter. So I've got it there. I'll draw a construction line that goes from the center up to the top. Make sure it's a construction line. That's good. So now it's also constrained. I'll draw a couple of lines, also construction. and now I need to give them an angle. First I'll make the ends coincident. Okay, and now I'll give them an angle. So I know that I have 16, so 16 divided by, 360 divided by 16, 22.5, and then the distance between one of these lines and my center, the angle, will be 22.5 divided by 2. Got it's perfect. So now I can draw this profile. So it will go from up to here roughly. You can just trim this bit and make this coincident. Okay, so it's already coincident, that's good. And now I can draw this line here. That's good. I'll give them an angle. And now what I will do, I will mirror these two lines. Against this line. And I will fully dimension that, just so it's constrained. Okay, so now that I've got that, I'll finish my sketch. I'll probably turn off my image, go on extrude, and now I'm going to extrude. Oops. Before I even try to do that, I will just trim my arc. So it does not interfere with my profile. And now I can actually extrude it. So I'll go on that direction where it says distance, I'll say 2. And then I'll select this face, so we'll extrude it up to that face. That's fine. And then I'll click on OK. So I've got my first tooth of my spline done. So now what we'll do, I will use another circular pattern to pattern this tooth around. So I have selected it. I'll select an axis, so it can be any of these round edges. And now I know that I want 16 of them. So Inventor will select even spacing between them, so that's fine. So all of my teeth are done. Now I need to taper them at an angle. So I'll probably be using probably my Y-set plane that would be fine. So I'll start sketching my white set plane. I will cut the cross section. I will use project cut edges again, and then I will project and project geometry the bottom of this tool, maybe this side as well, so I'll have a good reference. Maybe that as well. Yeah, there we go. So now I'm going to draw a triangle that goes from here to here roughly. Then it will go from here to here, and then it will meet exactly at my previous endpoint. Oops, this line, that endpoint should have been somewhere else. I will quickly redo this line. Let's go up to here, so you always have to be careful with your projected geometry, because sometimes it gets a bit tricky. And up to that. Okay, perfect. So now I'll give that an angle. Oops. 25 degrees. I will draw a line, construction line, goes from this midpoint down to this midpoint, and then I'll use the mirror tool again in order to mirror this feature on this line, and then click on apply. So that's all done. Now, yep, I'll click on finish sketch. It's fully constrained. I'll go on revolve. Select this one. Select this one. Select the cut option. Select axis, will be again my Z axis. And then click on OK. So now my teeth from the spline are also at an angle, the way they should be. And now all I have to do is just taper my gear teeth. So I'm going to use my Y-set plane. This gear seems the ideal one. It's right at the center, so I'm going to start sketching this plane. Again, slice graphics. I'm going to project cut edges. And I will also project some geometry across. I'm going to project this line, so we can see a little bit better. Now I'll draw an arc from here to here. I'll actually make it a little bit offset, because when I revolve it, I want to make sure that it cuts all the way through actually. Now up to here and back down to here. Okay, so I'm going to draw a line at the center again. It's going to be my construction line, and this time I will just fix it. Now I want to dimension this end. So that's actually, instead of using this dimension, I know that this is actually 1 mil. There we go. That's a cut. It's quite small. And then I'll give my arc a radius. Now I'll give this another dimension. And my arc was 24. Now I can just mirror this across to the other side. Finish my sketch, and I can revolve both of them. Cut around my Z axis. Now click on OK. So that's my gear all fully modeled. Has a spline, it has same number of teeth, the same diameters. Now let's have a look. Change the view style, make it realistic. Add some shadows, reflections. Make it perspective, and then add a more realistic color. Okay, so now let's bring back our first image from our first extrusion. Let's turn the disability for sketch on and have a look at it. So if we look at it from the front, we can't really see our teeth sticking out, can we? Well, the picture would be covering it anyway. But if we look at it from the other side, we will be able to see how close ours match the geometry. So if you look at it from the center, it doesn't really stick out. Obviously, if you move it up or down, you will be able to see it because we're on perspective. That's a bit tricky. If we try to put an orthographic, but again, the picture has been taken in perspective. So in order to properly visualize it, you need to look at it exactly from the front. So yeah, I think overall we did a pretty good job modeling this gear. Splines also look quite good. So yeah, that's it guys. Now if you want, you can take a nice render of it. What we'll do with these, I will probably export it as a STL file. Let's have a look at it. and that's going directly to the 3D printer in order to test the model. So yeah, I will post the pictures for you in order to carry out the exercise. If you have any questions, you've got my email, so you know how to contact me. So yeah, thank you very much for watching, and I'll see you in the next one.